Hi, welcome to Reinforced Concrete Structures course. So, I will give you a short introduction of everything related to GATE exam and who am I and all those things before going into the subject. So, obviously, who am I to teach you? So, I am a Siddiq Aliar. I am having a PhD in IT Madras and École Centrale Nantes in France. My PhD is related to fluid structure interaction. So I have a vast idea about fluid mechanics, structural mechanics and structural engineering. I had cleared GATE exam thrice in 2013, 14, 15 with highest percentage obviously scored around all the time. I did my masters in structural mechanics in IIT Madras and a doctorate I already told you. Then after completing my masters, before my doctorate, I was working in onshore and offshore platforms like designing a port, designing a jacket platforms, and execution of the jacket platforms, etc. So and also I was involved in planning and management before coming into doctorate. Other than else, from 2014, I am teaching 2014 and 15. I am started teaching GATE exam, all the civil engineering subjects, almost all the civil engineering subjects across the country. I had a vast experience of teaching from Kashmir to Kanyakumari, if you say, around 5,000 plus students. So, if you want, you can ask for a proof as mentioned there. So, I hope I am eligible to teach you something related to civil engineering, especially concrete structures. So, let's come to the GATE exam. So, first I will give you a short subject wise division of GATE score. So, if you divide the civil engineering subjects, so you have geotech, leave the max, geotech, max, environmental engineering, transportation, fluid mechanics and hydraulics, strength of materials and aptitude will contribute 70 percentage of the marks in your GATE exam. So this RCC survey, steel, structural analysis, all those things will contribute 20 percentage of your question paper, and division C, hydrology, CMM, construction management and irrigation mechanics will contribute 10 percentage of your question paper. So if you see overall in a from this idea you can clearly know which subject to, if you want to skip, if you don't want to skip it's fine, you can to study everything. If you want to skip, which subject to skip first, which subject you should concentrate, which subject you want to learn more, concentrate more, like that you can devise the subject to have a more clarity. If you see, if you take 100 percentage of the GATE, so and before that I want to stress more, other than civil engineering there are more lot of civil engineering exams in our country like RRB, AE, IES, GATE and lot local AE exams in your government, so etc. Structural engineering will always contribute around 20 to 30 percentage of any question paper if you take any question paper. So in structural engineering we have a lot of divisions that we will see in next slide. So if you see this table I have shown here is for especially for GATE exam. So if you take 100, like I mentioned in the previous slide, if 100 marks is for GATE exam, structural engineering will contribute 25 marks, geotech 15 marks, environment 10 marks, transportation 8 marks, and surveying 5 marks, max average 15 marks, and water resources like irrigation, hydrology will contribute 11 marks. Aptitude, obviously every year they are having from English and general ability, so they will ask for 15 marks. If you take above is the average of 2010 to 19. If you didn't believe me again, you see this slide. So these are the subjects we are, if you want to study GATE score, if you want to get into the top 100 rank in GATE exam or top 10 rank, you should obviously know all the subjects. If you see the division from 2012 to 2019, I have taken all the question papers and I have devised based on the subject. If you see, you can see this slide if you want. I think I will give you the slides also. You can see the more clarity which subject, which year, which how much weightage was there. But if you take an average, I have taken an average for structural engineering syllabus. You know, under structural engineering there are construction materials, engineering mechanics, strength of materials, structural analysis, concrete structures and steel structures. So if you take a previous year's average, how many percentage of marks has been asked in the GATE exam is for construction materials and management, which was the newly introduced syllabus in GATE 2015, 4% of the question paper will 4% of the questions will be from this subject. Engineering mechanics 2%, strength of material 6%, structural analysis 5% of marks, and concrete structures 4, steel structures 4. So 4 or 5% concrete structures. So in this course for today, it is an introduction course. We are going to more stress on concrete structures. I hope I make it clear. GATE exam 100%. From there, the GATE exam is divided into so many syllabus like structural engineering, geotech engineering, environmental engineering, like that. In that, we are going to see structural engineering. Under structural engineering, we are going to see this concrete structures, which will contribute 4% of your question paper. Under this is the GATE syllabus given for concrete structural engineering under concrete structures. So in working stress method, limit state method, ultimate load design method concepts. Okay, so design of beam, slab, columns, bond and development length, etc., and pre-stressed concrete and analysis of the pre-stressed concrete beam at transfer and service loads. These are the syllabus given for uh, concrete structure syllabus for securing that 4% of the marks. So scope of this course, we won't stress only on this GATE syllabus. GATE syllabus is very small. At the end of this course, you will be able, I would have detailedly explained how to use IS 456 throughout for designing beam, slab, column and footing, and also I will explain basic design principles. How will you design the what is pre-stressed beam, how will you design the pre-stressed beam, what are the losses you will inquire, and how much load finally it will take. So that I will able to explain you at the end of this course, if this course continues till the end. So as an overall, since I said I will explain it detail, so we are not going to stick only to the short syllabus of GATE exam. We are going to have a detailed content of what we are going to see. So first we will see introduction of concrete structures, and then we will study about limit state of collapse. In that limit state of collapse, we will study how to design a beam, under beam, singly reinforced beam, doubly reinforced beam, T sections, bond and development length, how will you put anchorage, etc. Then we will see how to design a column, how to design a slab, how to design a footing. Then we will go back and see how to design a same beam or anything based on limit state of serviceability. Finally, after studying these things, we will go and stress something on pre-stressed concrete. What is pre-stressed? How will you design? What are the losses you will inquire for the pre-stressed concrete structures? This will be the overall content for this course. Okay, so let's see the introduction of concrete structures. So chapter 1. So in this, at the end of this chapter, you will be able to know little bit about what are the different ideas are there, and how will you finalize the design load, how will you finalize the design strength, and what are the IS 456 recommendations. But this IS 456 recommendation will not be included in this video. This will be attached in the next video. So let's start with the general concrete structures. So I hope everybody civil engineering students who are listening here, you know what is concrete. Everything, everywhere you see the structure which has cheapest one will be a concrete. You see port and harbor structures, it's a concrete structure. So and you see high-rise building can be combination of steel and concrete, but mostly the concrete will be for the uh, so I think there was a clash in the slide. So these are the general structures available in the real life: port, harbor, high-rise and bridge structures and airport buildings. Yeah, so all those buildings, all those structures have major constitutions of concrete. We are obviously, I think you know. So I want to introduce first the general construction sequence, how the building, residential building is constructed. So this video I took from YouTube. So you see there will be a soil we will study detail in geotechnical engineering. First they will do an excavation depends on the depth, how much you want depends on the soil. There will be, first you will put a footing reinforcement as shown in the video. This footing reinforcement also again will be designed, it will be designed like a slab. From there the starter column reinforcement which will protrude out. So then we will do the casting of the footings. So step 1 excavation, step 2 footing. Okay, so then they will have a reinforcement for the ground beam which is touching the ground. Okay, so after the ground beam they will do it looks like they are doing a concrete casting for the ground beam. So next step will be like backfilling. Yeah, so they will do the backfilling and closing the footing. Since the footing it is over, and they will do the compaction of all the subgrade soil around, and they will fill the ground floor slab, mostly as mentioned here 6 mm or 250 mm center to center spacing, and they will do the casting of the slab. Ground slab is over, then they will start with the column. So there will column reinforcement, usually 8 mm 12 mm rods will be used. So then the column casting will be done. Usually when you see a under construction building, you will see this framed structure first before laying of anything. There will be a columns, you will see everywhere. Then there will be a laying of concrete blocks or wall. Usually we will have a brick walls. So after the brick walls up to certain level it is over, then they will have a roof beam, and the roof beam construction is over. Then you will have a slab, roof slab. The roof slab can be one way slab or two way slab, we will discuss detail. So the slab will be inserted from the beam. Actually there is some misconception in this video, because the slab and the beam will be mostly casted along, it won't be separately casted. Okay, so the beam reinforcement, if it is ready, it will be more like a T beam or L beam. We will discuss even detail in more. So this is the final roof slab, and they will do the casting for the slab. Okay, that's it. So I hope from the video you can rewind back and see, or you can even refer the same video in YouTube. So first they will do the excavation, then they will place the reinforcement for footing, then they will have a footing casted, then there will be a deck beam, then they will have a column, then they will have a bricks, or if it is a framed structure they will do the column, then they will do the beam, then they will fill the walls with either RC wall, means it should be started earlier, either they will use a brick walls, then they will do the final roof slab. So what you saw, there were 4 structures, 4 constituents: beam, column, slab. So slab can be defined by 2, either roof slab or footing. Footing will be a short span of slab, what you are seeing in the video. Okay, so at the end of the video what I am expecting you know, okay, these are the 4 constituents we are going to see, and at the end of this course you will be able to design what are the reinforcement required, what are the size of the beams, columns, everything here. Okay, so I want to show you another construction. So this is a construction sequence for a port. You see they are having a piles, so they are driving the pile. I want to sorry, so I think they are coating the pile, so they are driving the pile casing. Similarly they will drive the pile casing throughout the location. So this will be the step 1 of any pile construction, or they will fill the area. This they are doing like offshore. If they want to do offshore, they will fill the total area with the sand, so then the offshore construction will become onshore construction. Okay, so if you see they have placed the pile casings everywhere, and they will cut the top extra layers, they will place the reinforcement, pile reinforcement inside, then they will pour concrete. Actually pouring the concrete is not like this way, you cannot just pour the concrete from the top, because there will be a seawater, you have to extrude the seawater, and also they will use a trimmy type of concrete casting. They will pour the concrete from the bottom and then up to the top, they will fill from the bottom so that the concrete will flow at the top. Okay, so after placing the concrete, then they will go inside and they are placing, this is for anode, like a sacrificial anode, the steel pile casing which should not be get corroded if it is a steel pile. So they are placing a sacrificial anode, so that will sacrifice and it will not allow the corrosion. So the next they will place the pile cap, they are placing the pile caps and precast beams, and they will place the in place reinforcement, and they are again filling the beams. So now the beams is over, this is the berth wall, again they are filling the in place reinforcement and they will fill. This is for bollard, and they will place the precast slabs in the all the gap, and then they will start filling the final concrete. Okay, so most of the port construction will be precast, and they will bring to the site, they will put the remaining reinforcement, they will start pouring the concrete. So this is called fender. So this fender will not, when the ship comes near, this is bollard, so when the ship comes near the port, it won't hit the port, that will be avoided by the fender will take all the berthing energy. So this is for railing for the crane. I think this is fine. So I hope what you have seen here, for the port also there was a pile is nothing but a foundation, again there was a beam, again there was a slab, again the name will be different, it is like a pile cap, pile slab, deck slab, all those things, but all the stories are same. Slab is slab, beam, foundation. If you know foundation, if you know how to design a beam, if you know to design a slab, that's it. Any type of construction, everything will be same. Okay, any type of structure, everything will be same. Okay, so coming inside the structure, so you have seen two main materials we are using here. One is concrete. I hope in the concrete you know what are the things available. The cement will be used as a binder, binding all the aggregates together. Coarse aggregate, sorry the spelling mistake, it should be COA. Coarse aggregate will be the strength. Coarse aggregate nothing but a stone, that will be the strength of the concrete, and fine aggregate is only to fill the voids between. If you have 10 to 10 aggregates of irregular shapes nearby, there will be heavy voids inside, so you have to fill the voids with the sand. So if you fill the voids, or else the cement consumption will be very high, so we need a fine aggregate to fill the voids. There are a lot of purposes, it will provide a friction, some stories and all that. So fine aggregate is main purpose is void filler, and you will use a water. Without water the cement will not create the hydration reaction, and it won't the long story. Okay, we will have a detailed discussion of what everything does and what are the chemical composition of cement in separate course called construction materials. Okay, you can see here in this graph. So the sand will contribute 32%, aggregate 49%, approximately 80% will be aggregate, 10% will be cement, and 6% will be water. And we will have some admixtures also, physical admixtures like fly ash, so many things are there, and chemical admixtures for individual purpose, whether to quick setting, slow the setting, different purpose. Okay, so we will have a detailed discussion in some other course. Here you know what is concrete, what are the things inside the concrete, and what it does. Okay, so next material we use is mostly the steel composition. We will again this we will study detail in the next material. What you should know is there are the initial stages, they will use a mild steel. You can see the figure here, this will not be ribbed, and it will have a yield strength of 250. At the after 250 the material will start yielding. So they used a deformed setup to make the mild steel bar to go have a higher yield strength up to 415 Newton per mm square, or FE500 is also available in the market now. Generally for residentials we will use FE415, and for port and harbor structures as I told you we will use FE500 for a very high yield strength. Okay, nowadays even HOSD bars are replaced with TMT bars, but both the chemical compositions are same, there won't be any big difference. The how they physically achieving this yield strength matters. Okay, only that is the difference. So this is the Young's modulus, I hope you know, 2 into 10 power 5 MPa, and this is the coefficient of thermal expansion. I think there is a small there, it's 10 power minus 6, and Poisson ratio is 0.3. There is a story about coefficient of thermal expansion you should know. The concrete and steel, why we are having a concrete and steel as for reinforced concrete, why not different material, why not concrete and copper, why not copper and gold, something, so concrete and gold, why steel is mixed with concrete is both the material has a same thermal coefficient of expansion. So when the concrete expand, steel also will get expand. When concrete contracts, steel also will get contract, because both will behave in the same way when there is a temperature difference. So there won't be any induced thermal stress inside the concrete. Okay, so if you are providing a reinforcement as a copper bar, copper will yield more, so it will come out, there won't be any bonding between the concrete and copper when there is a I hope it was clear. So if both the materials different thermal expansion, there will be additional stress you should design for thermal stress. So it does, so our design will not include that to design a structure for thermal stress, because both the materials has same amount of thermal expansion. Okay, and in the market if you see the length of the bar available is up to 25 mm diameter bar. For if you are using in your structure less than 25 mm dia bar, up to the length of 12 meter is available. If you are having a bars greater than 25 mm, length to 6 meter is available. So why is it very important is, if you are having a structure or a beam for a length of like 400, sorry, the port will be 400. If you are having a high rise building of a beam of length some 12 meter, 16 meter, so in your maximum length available is 12 meter, even you cannot provide the 12 meter directly. So what you have to do, so the length of the beam is 16 meter and you have having a bar of only 12 meter. So you have obviously you have to buy a new bar of 6 meter or 4 meter, and then you have to cut the bar, and then you have to do the beam splicing. So the connection between the beam, you cannot always imagine to provide a single bar throughout the beam. There will be always a coupling, always there will be a splicing. So the splicing is very important. Even in column, even in beam, everywhere you cannot have only single bar, there will be multiple bars you have to place. So that factor depends on this one, what is available in the market. Okay, so this we will have detailed study in the chapter bond, anchorage and development length. Okay, so here we will have another short introduction of what are the methods available. I will go in short. RCC, there are three methods was there: working stress method, 1940s 50s method, and then they tried to impose ultimate load method. And then recently nowadays we are using limit state method, which is in American Concrete Institute, we will say LRFD, load and resistance factor design. So what is a working stress method? So we will use the working load. If you are sitting in a chair, your load will be taken as a taken for design, your load or service load. Okay, you will not design for a limit state, you will design only for the service load. And what is the stress? How will you calculate? Characteristic strength of the material divided by the factor of safety. What is characteristic strength of the material? So if for M20 it is 20 MPa. Characteristic strength we will do in 2-3 slides, you will come to know. I will give you detailed study about characteristic strength. So working stress method means the two things you should know: it is designed based on the service load, it is not designed based on the ultimate load. And service load means your real load, you won't multiply. And this working stress method does not have any load combinations. So you will not have a dead load 10 1.1 times, live load 1.3 times. So you don't have any individual load combinations for the working stress method. Okay, so you can either have a load factor or single load factor 1.5 times, 10 times, or 1.2 times, like that. You can have multiply only a single load factor. You don't have any individual load combination, and you are using only the service load. This is the two major difference. Third major difference with the other methods is you won't design for serviceability. Okay, because you are having a very such low loads, serviceability usually won't be a problem. Usually it won't be a big problem. If required, we will have some example comparing limit state method beam and working stress method beam. I will show you the load will be very less, so that the deflection won't never be a problem. Ultimate load method, usually nobody has a detailed study about this ultimate load method. The extension of this method is limit state, that we will see here. Only difference you should know is, from working stress method, instead of using a service load, we will use a collapse load, the load at which the structure collapse. We will take that load and then we will do the design. Okay, you see the material safety factor here. Factor safety in during 90s, 70s, 60s, they used for concrete 3 times. They were not sure whether the, you see, load factor 3 means really they were not sure whether they will get that particular FCK. Okay, if M20 20 MPa, if you are dividing by 3, obviously you will get around 7 or 8. Okay, so you are assuming that you won't get this 20, you will get only this 7, and then you are designing. So much of safety in working stress method. But in ultimate load method, you are having only factor safety of 1.5 and 1.15, which will be maintained in limit state method also. Okay, so in ultimate load method, you have to understand only the difference between there and here is you are having a ultimate load for the design. Okay, so coming to the real method, limit state method, this is how we are going to design the total structure. Our syllabus, everything is framed on this one, and after 2000, all our residential buildings across our country, everywhere they are using LRFD method or this limit state method. This method is a limit state, it is a condition just before collapse. If you are sitting in a chair, again, if you are 100 kg, if the chair can take, if the chair collapsed when you are sitting, so before collapse it took 100 kg. Okay, so the limit state is a condition just before collapse, how much load it took, the condition. Okay, that is a limit state up to that limit. So it is divided into two classes: limit state of collapse and limit state of serviceability. Mostly you will design for collapse and you will do the check for serviceability, everything. If you are starting your own company also, will come to realize, first you will do the collapse design, then you will check whether the deflection is okay, whether the cracking is okay, vibrations are okay, everything you will do. You will never design for limit state of serviceability. First you will do this and you will do the checking here. So under the limit state of collapse, you will design for beams, flexure, you will design for shear, compression, torsion. You have one more thing. Okay, everything is here. So flexure, shear, compression and torsion, you will design for all these. Before collapsing in bending, how much load it took. Before collapsing in shear, how much load it took. Before collapsing in compression, how much load it took. Before collapsing in torsion, how much load it took in torsional capacity. So that is limit state of collapse. Deflection, it is very easy. So how much deflection. You up to this much deflection you can allow, because when you are having a glass framed structure, so most of the walls will be glass. So when the beam is having more deflection, if it deflect more, the glass may break. Similarly, this cracking is very important factor in designing the vessels for concrete vessels for storing crude oils and something. So the spherical tank, water tank, everywhere, even for water tank the cracking factor is very important. So when the crack width is more than 0.1 mm, 0.2 mm, there will be a leakage of water can happen. So this is also a service based on check. This will change the total design. If we have time I will explain later. This is vibration check for dynamics. Fire resistance, this fire resistance came into all the code books only later stage of this American accident, where there is a, if you would have seen this flight in the, I don't know to do the politics, there was a tower collapse because of the flight accident, and the total fire total building both was collapsed only because of the structure was not designed based on the fire resistance. Okay, so the thermal resistance were never was in any code book before this 2001, I think 2001 incident. After that all the code book has this fire resistance. Okay, so then we will check for the durability. These are the different limit state of serviceability. We will see in detail in coming classes. So I want to explain little more about limit state of method. So what is this difference between limit state method and working stress method is, you see here. So this is the load you are expecting in your lifetime. Consider you are having a building. The building, I am expecting some 100 kg of load throughout the maximum 100 kg. This is like throughout the lifetime. Okay, and this is the capacity. So this is the capacity like 150 kg. 150 kg is the capacity I am designing for. So at some particular situation I am taking some risk. So this is the risk of failure I am taking. If you didn't understand, so this limit state method, what I am doing is, so far the load which has, I will design in the limit state method, I will design for a characteristic load. This characteristic load is nothing but it is the load which has 95% probability of not being exceeded in the life of the structure. Means this sorry, this is a probability curve, this is a median, I was telling it's a maximum. So this, if you see in the total lifespan of my structure, if this is the maximum load I am expecting like 200 kg, so I will design for 95% of probability, I will design for some 175 kg. Okay, I will design for this 175 kg such that 175 kg is the load which has 95% of chance of not being exceeded in the lifespan of the structure. You can see this is 175, this is 200. Less than 175 is the total lifespan. Only 5% there is a chance that the during the lifespan of my structure the load can exceed. So I am taking a risk of some 5%. Similarly, this for payment design they will take a 2% of risk. Okay, I hope it is clear. This is a capacity curve, this is the load curve. So in this load curve I am taking a risk of 5%. This is the risk of 5%. This is the capacity. The capacity may come down during that 5%. That's what it means. So this is the load and resistance graph. If you want more detail I can explain if you have asked me, or you can contact me again, but this is the total story. Okay, this is the load, this is the resistance. I am going to consider load, I am going to take a load when the such load 95% of chance that the load will never exceed during its lifespan. What are the load means? I am telling so much of loads. What are the loads? The load is nothing but dead load, live load, wind load, earthquake load, etc., which will act in the building. When there is an earthquake load, when at a time wind load and earthquake load is not considered in the design. Okay, so when there is a earthquake load, you consider only the earthquake load. When there is a wind load, you consider only the wind load. If you are combining both, then the structural, I hope you understood, then you have to design for very high load, which will never happen. So you won't expect the heavy wind and heavy earthquake at the same time. So you should be more conscious about designing that. So or else the structure will be very high and very expensive. Okay, so this what I was telling in the earlier, this 5% I am taking the risk. I am only considering 95% of the span. Okay, for that in the probability table, this k value for 95% probability is 1.65. So how to determine the design load? So when I am having 5 type of, consider I am designing a slab. For that slab, I was given Monday I will have 100 kg. Tuesday, like consider a slab having a classroom, 100 people will attend. For Tuesday, 170 people will attend. Thursday, Wednesday, 500 people will attend, something like that. So they are giving me 5 load. Monday to 100 kg, Tuesday 120 kg, Wednesday this much kg will come, Thursday 200 kg, Friday 500 kg, something. So this many kgs of load will come for 5 days. For which load you will design? You cannot take the extreme load and design. That will be totally different course. So I am going to take some risk. So this is the formula to calculate for which load you will design. Okay, so F equal to the characteristic load. For the load which is design is, I will take a mean plus this probability of 95% existence plus the standard deviation from the mean, how much each load is deviating from the mean. So I will show you with an example. So consider there is a live load acting over a structure at 5 different, they have given me 5 live load, 30, 20, 15, 45 and 50. So they have given me 5 live loads. Which load you will take for designing? Okay, so consider that's what I told you. Monday 30 kilonewton is acting, Tuesday 20, Wednesday 15, Thursday 45, Friday 50. So among this, which load you will take for designing the structure? You cannot design for every day. Okay, you have to take a fixed number. That number is 57. How they fixed it? Step 1, you take a mean. So I am taking average of 30 plus 15 plus everything. So I am getting average of 32. I am finding the standard deviation of, I hope you know what is standard deviation, or go through yourself. So if I take a standard deviation from the mean for each load, and then I am getting 15.24. When I substitute here F1 plus Ks, so I am getting a load of 57.16. So I am designing for 57.16 as the live load. This is the answer. And remember a hint, always when you are designing for load, your answer will be always little higher than the highest load. You see 50 is the highest load. Here I am designing for a 57. Okay, so on next problem, one more problem is, this problem is for load combination. This is also one of the major difference between working stress method and limit state method. In limit state method, we will have a load combinations. You can change dead load some factor, live load some factor, earthquake load some factor. So you can have different factors for each load, which was not possible in working stress method. This is also another big difference in limit state method. So anyway, so consider they have given a, so in a building, dead load 150 kilonewton is acting, live load 250 kilonewton, wind load 25 kilonewton, earthquake load 32 kilonewton is acting. Among these 4, which load? You cannot design for every individual load. You have one final number. Which number you will design? Okay, so for design load of collapse, you will use this formula: 1.5 dead load plus 1.5 live load. It's very famous. You should know this load factor is 1.5, and 1.5 dead load plus earthquake load combination, dead load plus live load plus earthquake load combination. Either you can use wind load or earthquake load. Okay, so here what I have used is earthquake load, because earthquake load has a higher intensity. So use these 3 combinations, dead load plus live load, I am getting 600, dead load plus earthquake load 273, 3 combinations 518. So obviously I will took highest value for the design, 600. So similarly design load for service, for design load for service load you won't design for 1.5, then it will be very stupid. Always service load, what is actually happening is 1, you are designing for extreme cases 1.5. So for a service load, usually you see the load factors will be always 1. So you do this combination, dead plus live, dead plus earthquake, dead live load earthquake. Here you got 400 kilonewton. So for checking all the design serviceability case, you will use this load for checking. You won't do this one. If you do this one, then you will have again failure in deflection cracking. So then you will redesign. So don't do that. Design load for collapse is this load, serviceability check is this load, and this is the formula to do that when you are having multiple loads. So I hope this is very clear, and everything is in the slide. Okay, so next, how we, finally we are almost at the end. Now from last few slides you know how to calculate the load. Now how to determine the strength, because I am applying a load over you. If you are strength enough, you can able to tackle the load. So how to determine the strength of the load? Strength of the material. Okay, so strength of the material is determined by this partial safety factor in limit state method. This partial safety factor, usually I have shown you in working stress and ultimate load method, it is nothing but 1.5 and for concrete and 1.15 for steel. For serviceability is 1 and 1. Okay, again how characteristic load is 95 percentage, like 5 percentage exceeding is fine. Okay, I am only going to take 95 percentage. Similarly, I will take for strength also only 95 percentage. 5 percentage of test results are okay. Okay, so if you didn't understand this characteristic strength, I will tell you a little example. Consider I am casting 100 cubes. I have a mixed design for M20 and I am making cubes. I am making 100 cubes. I hope you know what is cubes. I am making 100 cubes and I am testing for each cube. I am taking 21, second cube 23, third cube 26, fourth cube, like that. I am having 100 cubes. I am, if I wanna say that my cubes, my mixed design is M20, at least 95 cubes should have strength more than 20. Okay, 5 cubes can fail. That's the story here. 5 cubes can fail means it can have a lesser value like 17, 16, less than 20. If I want to say my strength is 20, if I am casting 100 cubes, 95 cubes should have strength more than 20. Okay, so you can replay and listen clearly. So 95 percentage should have more than the expected results. 5% test results are expecting to fail is fine. Okay, so the only difference here from the design load calculation, this is strength calculation, this is load calculation, is only we will have a minus symbol here. So there was a plus, there here it is a minus, because we don't want to believe us that the strength is very high. Okay, so from the mean we will subtract the standard deviation 95% of this value. So I will end with this class with an example for the strength calculation. So consider I casted a cube again. As I told you now, I got 5 results. I casted a cube, 5 cubes. Each cube, when I break the first cube, I got 28. Second cube, I got 33. Third cube, 30. Fourth cube, 18. Fifth cube, 40. So what is the result? What is the strength of my cubes? Because I casted everything from the same cement, everything, same mixture, but I am getting 5 different results. So if somebody is asking you what is the final result, so you have how to tell is these 3 steps. So step 1, again take a mean. Taking the mean, I am getting 29.8. Find the standard deviation of all the values from the mean using this formula. You will get 8.03. So substitute in this mean minus ks, then it will have a result 16.507 MPa. So when I break a cube of this 5 different values, if I get the final answer, you should tell outside is 16 MPa is the maximum the strength the cube can take. And remember a hint, always for the strength calculation, the answer will be lower than the lowest value. Okay, here the lowest value is 18 MPa, you got answer 16 MPa. Remember that always the answer will be the lower than the lowest value. Okay, so with this we will close this introduction class, and thank you for CGP Career Avenue. If you are interested and if you are motivated towards the future classes, please let me know. Okay, thank you.